Welcome to Season 6 of the Prosthetics and Orthotics podcast. We are absolutely thrilled to have you on board. We're talking to experts who know their stuff, the patients who've experienced these technologies firsthand, the vendors who provided the tools, and the thought leaders shaping the future. Together, we will uncover the ways to make the lives of those relying on these incredible technologies even better. We hope these discussions are going to be the highlight of your day.
Hi everyone, this is another episode of the Orthotics and Prosthetics podcast with Joris Peels and Brent Wright. How you doing, Brent?
Hey, doing well. Yours got back from AOPA, and I tell you what, it was the overall excitement just around not only orthotics and prosthetics, but around the digital side of things was pretty amazing. You never want to get stuck on the last day after the teardown of all the, the expo and all that stuff. But we've had Jeff Aronstone on before, and he set up they called it a digital showcase, which allowed anybody that had anything digital to scan a model, and there was kind of a case study, and then they were able to go like table to table and see how these different companies solve for that case. And it was packed. I mean, it was like 2 hours, standing room only, and just a lot of interaction. It just it was awesome. So really, really neat, and just a great job by that team.
Okay, and overall, how was the experience? Are you is it growing? Were there more people, more stands?
So this one, I think it was definitely very busy. The layout was very interesting because the expo hall was not always where the classroom was, so you had to be very intentional going either way. But I actually thought that was a very good thing. And, you're walking the skyways that's going across the roads and meeting people as they're going either way. And so I thought they did a great job with the show. And yeah, I mean, I've got no complaints about it other than, I booked the wrong hotel when I got to the airport. So when I got to the airport in Indianapolis, I'm like, oh boy, that's not near downtown. So I had to switch that. But other than that, it was good.
Okay, that's cool. And then, so overall, I mean, was there a lot of additive there? Did everyone have additive? Is it growing?
So I would say there was a lot of additive, but what I found interesting too, though, is that there was attrition from last year. So there were companies that came in big and bold last year that were not there this year. Yet they might have been around and kind of lurking. So I thought that was interesting, but it seems like people are getting more focused and they're more educated around the questions to ask and such. And so I think that was exciting. I talked to multiple vendors, and they said people are now asking the right questions just because they're more educated about truly what the technology can do.
Okay, so maybe a little bit of the hype is gone, maybe less interest, but more real interest and more real knowledge. That's always good to see, right?
Absolutely. Yeah, I think that's where we're at for sure.
Okay, cool. Good to know. And so who's on the show today, right?
Well,
somebody you met at IOPA, right?
Well, yeah. So, and we follow each other on LinkedIn and such, but I really appreciate what he's done with this company. And we've had Chris Baschek on before, who's the clinical director of Point Designs. But Levin Sliker is on with us today, and he's kind of the brainchild of putting all of these pieces and parts together for Point Designs. And, Point Designs is just such an amazing product that is very niche and for partial hand amputees. But what they're doing is they're doing metal 3D printing, they're doing thermoplastic 3D printing, digital design, using some automation, and using that automation to train other designers. And they do some wicked cool color stuff as well. And I mean, they're making a massive impact in this underserved partial hand community and patient population. So I'm really excited to talk to him about the journey and what they've got going.
Wow, thanks, Brent, and thanks, Yoris. It's really a pleasure to be on the show this morning. That was a really gracious introduction.
All right, super cool. So how did you first get involved with the ONP world?
Yeah, that's a really good question. For me, it dates back to my grad school days and post grad school. I really kind of lucked out, I would say. I I guess I'll go back even further. I'll tell my story from the start briefly. I grew up in a household. My parents were veterinarians and they owned their own business. So I grew up running around a veterinary hospital, and I got really interested in the medical field kind of early on, and then also got exposed to running a small business. Fast forward several years in grad school. My focus in grad school was totally unrelated. I was designing surgical robotics. But after graduate school, I took a job as faculty at the University of Colorado, Denver, on the Anschutz Medical Campus. And it was there that I got involved in assistive technology. So I was actually working on a lot of different projects in the assistive technology field, and started working with Richard Weir and Jacob Siegel at the university on this prosthetic finger project. So Richard Weir owns a EOS M270, which is a metal, DMLS 3D printer. So it's kind of interesting when you've got a tool like that. The saying is when you have a hammer, everything starts to look like a nail, right? So when you've got an M270, you start to 3D print everything. And it turns out that this was actually a really good application for that. So we started designing prosthetic fingers. Oh man, probably back in 2013, 2013 to 2015, we were really heavy in the design phase, still at the university. And in about 2015, we got the project to a point where we really started thinking seriously about commercializing. So in 2016, we started the company Point Designs to commercialize this technology.
Okay, and then so Point Design. Well, did you want to start a company? Or did you kind of have to? Were you like, oh my god, this is such a business opportunity, or did you have to bring it to market? What was the cart first or the horse? Let's say.
Well, I would say, I would definitely say the need was there. We identified the need. Richard Weir actually, he's very connected in this field. He's been on the research side of the O&P field for his entire career. He started his career at the Research Institute of Rehabilitation Institute of Chicago, now Shirley Ryan. And he developed some really good relationships with prosthetists. He actually went through O&P school himself, and maintained those relationships throughout his career. So he's well connected, and really, we identified the need for a robust, durable prosthetic finger, and we were trying to fill that need. So I would really say the need was there. We were trying to fill the need. We got the project to a point where we think we were, and so we created the company to we really did think that the business opportunity was there. We knew that the patient population that we were trying to serve was underserved historically, and we thought we had something that was truly going to make an impact.
And so, like, maybe people didn't see the. I don't know if everybody like people just like pick and choose their episodes or follow them all. So just in case you didn't see it earlier, you don't know what you are. What's the differentiator about your hand? Or the finger? What is it really different about what you guys do?
Yeah, great question. So, first of all, every device that we develop is catered towards the people with partial hand amputation. So that's amputations distal to the wrist. So now we've got 6 devices on the market. We started with one, and our first device was a full finger prosthesis for amputations near the MCP joint. So the MCP joint is the joint that connects your finger to your palm, essentially. So it's your proximal phalange to your metacarpals in your hand. So it's the most proximal joint at the base of your finger. And so when we design our devices, the feature that's at the forefront of our minds always is durability. The need that we identified pretty early on was that this patient population was underserved, and the devices that were out there were really inadequate. We heard a lot of accounts of devices breaking or really not holding up to the tasks and environments that people really wanted to use these in. So we took the approach to design something very robust. So we designed something very simple. So it's all of our devices have a spring-loaded ratcheting mechanism, and they're built out of non-corrosive metals. So we use titanium, stainless steel primarily, and it's a mechanical system. So no batteries, no electrodes, no electronics, very simple, durable system. You can get it wet, you can get it dirty, and the mechanism will continue to work. So the fingers are positionable. You can press on the backside and they click or ratchet into a number of different positions. Once they're in position, they can you can oppose against them, and they can withstand quite a bit of load. And then there's a couple of ways to release them. There's a spring back mechanism, or there's a button as well that releases them. So it's I guess what differentiates us is just the simplistic mechanism that we employed to create a really durable device. And now we're 7, almost 8 years into sales, and we track repair rates. And one of the things that I'm really proud of is we have a less than 3% return or repair rate on all of our devices, which I think for the upper extremity field is pretty remarkable.
Do you think? I think it's interesting that you look, you're thinking about this robustness and this durability from the very outset, right?
Yeah.
And because it's really, I could easily see if you're trying to replicate a finger, if you're looking at a finger, if you either do it in a kind of like a, kind of looking at the scans, kind of the biology kind of way, you're going to come up with something super intricate, maybe with bellows and tendons, all sorts of stuff. And to me, that would really maybe, be a very fine-tuned finger, but it may not survive, opening a door or carrying a bottle of Coke or any kind of real life type of environment, right?
Right. Yeah. Yeah, absolutely. Yeah. So that's absolutely correct. I mean, I think mechanisms in general tend to be more robust. The more simplistic and more simple they are. So, yeah, we took a couple of approaches. One is that ratcheting mechanism, but then we also did a few other things to simplify the mechanism. We do have a 3-jointed finger, which is anatomically accurate. Your finger has 3 joints and 3 phalanges. And that's also unique. Other fingers that are out there only have 2 joints. But we simplified that by connecting those 3 joints. So all those joints flex, and we did a lot of, we based the kinematics off of real world data. So we did try to optimize those kinematics, but it creates a really intuitive system. The user only has to use one side to position the finger. They can just press the finger up against an opposing surface. So it can be their thigh, a leg, or whatever. They don't need their opposite side. So it's actually, turns out it's very useful for people with bilateral amputations as well.
So why? So you talked about the different iterations that you did, and I love that you kind of landed on these mechanisms and not something that was body powered. But I'm guessing you did explore some body powered. So can you just explain why you took that fork?
Yeah, absolutely. And that's a great question. We get asked that a lot. And we actually get a lot of requests for body powered versions. The reason we haven't explored that, or we have explored it. The reason we haven't focused on it is a couple. One is it's hard to duplicate the durability, and there's some inherent inefficiencies that are coupled with body powered devices that are really hard to get around. So, the first is, when you've got a body powered device, you have to drive that with you have to drive it with a residual part of the body and an adjacent joint typically. So whether that's a residual part of the finger or part of the hand, so you're driving it with a wrist flexion extension or MCP flexion extension, there's some efficiency loss. And I can't remember the numbers off the top of my head, but it's something probably around 60% efficiency. So you only get about 60% out of what you put into it. And so that means it's really hard to design a device where you're going to get grip strengths at the distal end of the device that are adequate to really do a lot of the heavier duty tasks that we know are important to people. So we just decided to go with a static kind of passive design. So, you can still position the device, but once it's positioned, it's locked into place. It doesn't require sustained muscle contraction to maintain that position. And therefore, once it's in place, people can do some of the heavier duty tasks that we know are important to users.
And how do you go forward from this? Because you have like this one successful product. I mean, it's got to be like scary because you're kind of wedded to it. Do you do feet? Do you like we were talking before, doing other body power devices? Saying no is a really big part of a designer and an entrepreneur, right? So designers always want to solve stuff. So they go like solve stuff that maybe nobody wants to pay for being solved. And entrepreneurs always want to like proactively engage stuff. So maybe you're saying yes to a lot of things. So how do you say no, I think?
Yeah, it's a really good question. Something I'm learning to be better and better at as life goes on, both personally and professionally. But one of the things that we decided kind of from the outset of this company was that we were really going to focus on the partial hand space, and that's it doesn't mean that will never change, but that really did it did focus us, and so it's really created an environment here where the engineers and the designers are they kind of know from the onset that the devices they're developing are for the partial hand space. So yeah, we took that first product, we call it the point digit. It's that full finger prosthesis. And we started applying that same principle to other levels of amputation within the hand. So a partial finger, a thumb, and now we've got several modular components to that thumb that add various degrees of freedom depending on where the amputation of that thumb is. The thumb is a very complicated part of your hand. There's a lot going on there. And so, really our focus was the partial hand space. And that's primarily because we know that population is has been underserved, and there are, as you move down the arm, the incidence rate of amputations increases. So we know there are a lot of people out there with partial hand amputation, and we know that it's been an underserved population, and we feel like our best, the way to make the biggest impact is to focus on that particular population. So that's kind of what motivates us is just really focusing on impacting and helping that patient population.
And what was it like to go to market for you guys? Because you've got, it's an interesting development and design, but it seems expensive and it seems long term. Did you find investors to do this? Did you do this yourself? How did you find the money and time to do it?
Yeah, really interesting question. So yes, on one hand, it is very expensive. On the other hand, though, the additive manufacturing approach saved us a lot of upfront costs, in my opinion. And that is actually what enabled us to get to market relatively quickly and also without a whole lot of upfront capital, because we had access to a machine through the university, and the university did, we essentially use the university as our first vendor. We don't use them anymore. We've scaled enough where we have, our volume requires more than just that one printer. But to start, we used them as a vendor. And basically the additive manufacturing approach enabled us to get to market quickly, and also make quick design iterations early on. And it also enabled us to collect data. So one of the things that we didn't quite know going into it is, for example, one data point that we didn't have is, what sorts of sizes would we need to offer if we standardize sizes. So we actually started out making fingers in custom lengths. So we would take length measurements from our customers. We would scale the model. We'd print it. We'd do a one-off print. We'd finish it, assemble it, quality control, ship it out. And we did that for about 6 months. And over that 6 months, we got enough data that we figured out, okay, if we standardize sizing, we could offer these 5 sizes, and we could fit, the majority of patients out there. So then we standardized sizing, and also through that first 6 months, we did iterate the design. I mean, we were constantly trying to collect feedback from our customers, and we quickly iterated that design and improved upon it over that first 6 months until we discovered that we could standardize some of these parts. And then once we were able to standardize parts, then we kind of moved into scaling production and keeping an inventory of parts on hand. And so, I really do think that without the additive manufacturing approach, none of that would have been possible. We would have had to invest in tooling or molds, or we would have had to commit to certain, standard sizes. It would have been a lot harder to iterate the design early on. And then to answer your second question, we were 4 founders in the company. We initially invested our own capital to get the company off the ground, but we've actually managed to not take on a significant outside investment, and we've been able to bootstrap and organically grow the company from day one.
Okay, that's super good that you've been able to grow like that. But then, yeah, you make it sound really wonderful. We iterate designs, we keep changing stuff, and it's like no capital. The additive is super easy, right? So you just but I think the three of us know that it's a little bit more complicated than that, especially metal, right?
Oh yeah.
And so especially metal, like we talk mostly here on polymer, right? Because it's more check sockets and stuff like that. That's where more people are involved in. But metal, it doesn't come out of the machine like you want it the first time, right? That's a big difference in polymer, where it should, if you stick to some design guidelines, it should come out kind of how you want it, at least. But metal, it often doesn't. So what was it like for you, that learning curve with additive?
Oh yeah, really good point. So our one of the advantages of our team is that we really were, and I think still are, I would consider ourselves kind of experts in the additive, especially metal additive manufacturing. That machine, that original EOS machine, was acquired really pretty early on when additive metal manufacturing became a thing. So we had a lot of experience. Almost, by the time we started this project, we had a good 6 or 7 years of experience using that machine and coming up with some of the design guidelines for designing these types of parts. However, you're absolutely right. The especially when it comes to metal additive manufacturing, there are a lot of challenges. First and foremost, when those parts, well, for those who don't know about the metal additive manufacturing process, basically what happens is the machine lays down a layer of powdered metal. That layer of powdered metal gets sintered via a laser to the layer beneath it. And so everything's built layer by layer off of a base plate, or base plate is made out of the same metal as your metal powder. So at the end, you get this big metal chunk, and you have to cut the parts off of the metal platform. And then you've got metal support material. And so your parts require a lot of post-processing. So there probably maybe more important than the design of the part is actually the design of the support material. Designing parts, and they go hand in hand. You have to design parts thinking about how they're going to be oriented on a build plate as they're being printed, and minimizing external surfaces in particular that are going to require support material, because as a designer that support material will have to be removed, and then that external surface will have to be finished to match the finish requirements that you have. So there's a lot of forethought that goes into a part. More so, I mean, you have to do this with subtractive manufacturing as well, but it's a very different mindset when you're designing parts for metal additive manufacturing, taking all that into account. And then the other thing, this is particularly true with titanium, not so much steel, is the warping that can happen in a part as it's being printed. As titanium is printed, a lot of internal stress is built up in that part. So again, this relates to support material. So you have to design your support structures to adequately support that part so that it doesn't warp during the print, and it holds its form until you're able to do a heat treatment to relieve that stress, those internal stresses, and then cut the part off the plate. So there's a lot that goes into it. And yeah, there's a huge learning curve. And then that learning curve, if you decide to switch materials from, say, steel to titanium, that, same part that you designed that's going to get printed in steel might not work in titanium. So, there's a lot to consider.
That's super interesting, even about the support structures and the metals and knowing how things warp. And I guess that's one of the benefits of having an expert on staff with Richard, right?
Right.
That's kind of a hack. So I kind of put point in BC, and then we say ADFAM, right? So BC means before Chris Baschek, yes. And ADFAM is now. So tell me about that journey of now not only taking the 3D printed fingers, which are amazing, but then it was very clunky doing it traditional manufacturing, and
Yes.
and Chris has shared some of those stories and pictures and such, but then moving into this kind of additive manufacturing realm of the socket itself. Tell me about that journey.
Yeah. Great question. And I'm gonna start BC. The story starts BC before Chris. And really, we at Point Designs before Chris, we really were starting to think about additive manufacturing for socket technology. I actually think you had, Brent, you had a conversation with one of my engineers a few years back. I think Ben was his name. And you were very gracious in kind of helping us get set up. I think we had some questions about scanners at the time, and that was before Chris. So, we really were kind of moving in this direction. And what prompted that was, we're really fortunate. We have a great team. And one of the things that our team does really well is they maintain great relationships with not only our customers, but also, other people in the field that are important parts to the puzzle, as you guys know, right? It's a there are a lot of people that get involved in treating someone with an amputation in that rehabilitation process, including the payer, right? And so our team has a really good, they have good rapport with a lot of payers, and so we actually started to hear some feedback from payers that, hey, some of these outcomes that we're seeing aren't the best, and it's not your fingers, it's the fabrication. So it's how they're being applied. And at the time, we were essentially selling componentry to our customers, and then it was on them to figure out how to do the fabrication. So they would either outsource it to a central fab facility or they'd do it themselves. And for those of you who are familiar with fabrication, upper extremity fabrication and partial hand fabrication, it can be a tricky, it can be a fairly tricky fabrication, especially if you're not used to it and you don't have a lot of practice. So the end result was that some of the outcomes were not ideal, and we were hearing that from some of the payers. And so we're lucky to have that rapport with the payers. They gave us that feedback, so we were like, what can we do? And what the obvious answer was, well, let's take over that process. So we started looking into that, and ultimately what the stars all aligned, and we decided to collaborate, bring on Chris and collaborate with him and start up a whole new facility out in Salt Lake City, and start to do our own fabrication. And Chris, as you know, he is very passionate about additive manufacturing on the fabrication side of things. And so we basically decided to hire the expert, hire the guy who's very passionate about this, and kind of let him run with it. So that was we made that decision in January 2022. By May of 2022, we had our fabrication facility pretty much up and running, and we were starting to take jobs. And so now we're a year and a half into that whole process, and it's going really well. So we do have a really nice process that Chris has helped come up with to really to provide really nice, well-fitting, definitive prostheses using additive manufacturing for the frame in particular. We're still doing rolled silicone, so we haven't moved to additive manufacturing for the liner, but we're leveraging additive manufacturing for the frame.
So, and that's what I love, Joris, on what they're doing. I mean, obviously you've got the fingers, you still have the frame, but they have this very, rolled silicone, I don't want to put it at the same level as printing metal, but it's not an easy process. And that combination that you guys have found with the rolled silicone, that 3D printed frame, has been amazing. And then just the modifications. I was talking to Chris at AOPA about how he does all the manufacturing, or even the modifications for the manufacturing of that device. And man, those things are super secure. And so it seems like you've cracked that recipe, right, of that. But what I love is not only is it a niche, but there's also a barrier to entry, right? It's not like somebody can come in and copy what you've done.
Yeah. I mean, I think that's all true. I mean, Chris and the rest of his team have come up with some really interesting tools, digital tools, really, to kind of streamline that process and make those prostheses, really optimize the outcomes, both with respect to strength and suspension and optimized alignment. And really, I think that's kind of where I see the most opportunity is really kind of honing in on those processes and making things as efficient as possible.
Cool. Now tell me a story, not Jeff's story, because a lot of people have heard that one. But tell me a story that just is like one of those things where, man, I just love what I do, and I'm glad I'm part of Point Designs and this team of a difference that it makes in a patient.
Yeah. Yeah. So this story that comes to mind first, there are many, but the one that comes to mind first is this kind of dates back to probably ISPO 2018 in Japan. We had been working on a size extension for that original product called the Point Digit. The the fairly early on, we discovered that the smallest size we could make repeatably and reliably was not small enough. So it took us a few years, but we redesigned the digit so that it could scale smaller, and we came out with a size extension so that we could accommodate people with smaller hands, including children. And so I remember having a conversation with Wendy Hill in Kobe, Japan in 2018. And I was telling her about this new set of sizes that were coming out. And she got really excited. She had a patient, her name's Ava, patient of hers in Canada. She's a pediatric patient. They tried really everything. They kind of exhausted all possibilities. And the activity that this girl really loved and was passionate about was riding her horse. And they couldn't come up with a solution where she could securely hold on to her reins and do horse riding like she really wanted to. So we decided to partner with Wendy and her team, and she was the first pediatric patient that we were able to help with this new set of sizes, and it completely changed her ability to do that activity in particular. And she's really excelled, and to this day, I mean, this is almost 5 years later, she's now a teenager, and she's continuing to ride horses, and she's able to pursue that passion, which I would say in part is due to the devices that we've designed, and it's been really amazing to be a part of that, and that's really what motivates me. And actually, since then, when we initially provided the fingers, we weren't doing fabrication, so Wendy's team did the fabrication. But since then, we've fabricated her a socket too, and so she actually really. I just spoke to her a few weeks ago, and that socket that we fabricated is working really well for her.
Well, that's wonderful news. That's a really wonderful example. But I'd like to circle back a little bit on the metal printing front, because we talked a lot of times about the business case for polymer, like kind of desktop type printers. We think that's really super obvious, cheap. For a couple of $100, you can get in this industry, trying to figure out what works in 3D printing and what doesn't. Now a bigger MGF type system, there's a business case if you make an X number of sockets in a month or something like that. But the metal printers, if you're going to, like you guys do, base your product on metal printing, at what point do you actually buy one of those things? Or is it like your advice, never buy one of these things? Let somebody else who operates it operate it, and just design for it?
Yeah, really good question. So far, we have not invested in one of those machines ourselves. And so my advice at this point is don't buy one of those machines, because they're very expensive. They require a lot of infrastructure and space, and they do require technician recalibration. And so we've decided to just partner with a manufacturing. We have a really good manufacturing partner who, that is all they do. They just do DMLS printing, and they do a lot of it, and they do a lot. They do high volume. They have a lot of high volume accounts. And that has been that's been successful for us, at least for now. That may change, but for now, that is a very good point. The metal 3D printers are, they require a big capital expenditure, and also I think the technology is still fairly young, and so I would argue that by not far, it doesn't take long for that technology to become obsolete. And so if you're going to invest in a machine and 2, 3, 4 years later it's obsolete, that's not a great investment.
Well, yeah, it depends. I mean, qualifying parts of them are really hard as well, right? So, and getting it up and running in a really tight kind of tolerances and all that kind of thing is really difficult. And yeah, they cost about like $200K a year just by sitting at them to just sit there and do nothing.
Yeah.
Right. Yeah. Investment's like $1 million, but you'll probably need an additional $1 million or something like that to kit out your room, HVAC. You need one of the big Linden gas tubes,
Yep.
And also, just in case someone's thinking about this, I haven't found out how to make the economics work with just one machine, unless you're like hyper specialized in doing like satellite parts and stuff. But even that's really, really difficult. If you would go through, you would really need 2 to 3 of these things. So then you're looking at like, in total, like 3 to 5 million investment, and to really make that work in terms of the people you would need for it. In terms of just utilizing those things to a way that makes it kind of semi-profitable. It's really difficult to make money on a DMLS. It's also called powder bed fusion, by the way, 3D printer, a metal powder bed fusion or laser powder bed fusion 3D printer. It's a really difficult thing. So I would, this case, I mean, for the powder thing, I'm like, well, I don't know. You could try both ways. It depends on, how much money you have. But the metal thing, I would really leave to really specialized companies, unless you really need that extra time or you really can utilize the whole build volume in the machine every week, not just 1 week, but every week.
Right. Yeah, I would totally agree with that statement. And that's what we've found so far. But yeah, it is something that we continuously monitor, and there may be a point when it does make sense to own one of those machines.
Yeah, totally. I mean, I think there's some interesting things going on. Like One Click Metal has like cheaper machines, a couple $100K, with installed and well. So that's much cheaper, and they're much more newer still. But still, that for a lot of like parts, that could be a solution. So they are getting a little bit cheaper, and some people are value engineering them right now. And there's some Chinese ones coming in. So there are some interesting things. But this is like the metal thing is really like a very tough environment to operate in, I think. And just about. How do you have any tips on finding a good supplier? I mean, is it because it's like, it's a classic agency dilemma,
Yeah.
The guy knows stuff that you're paying him for, but then you don't know what he knows to determine if he's a good guy because you know nothing, because otherwise you wouldn't need the guy, right?
Yeah, no, exactly. Yeah. I mean, our strategy there has been to find suppliers, and we have many actually. So A is redundancy. So in case something happens with one supplier, you do have a backup that's ready to go. But really, I mean, the best suppliers that we have are the ones that are very transparent with their process and have a really well-defined verification and validation procedure on their end. So, anytime we develop a new device or technology, a product, we have our verification and validation processes that we do to, verify strength, life cycle, manufacturability, assembly, quality, all that stuff. And then our manufacturing partner has their own verification and validation process. And the primary supplier that we use, they are very familiar with manufacturing medical devices, class 1, 2, and 3. Medical devices. So their processes on certifications on their end are actually more than what we need for our devices, but it just makes them, they're very well equipped to manufacture our parts for us.
Is it PIDT tangible? It's not a long list, huh?
Yeah. So our primary vendor, primary partner that we work with is actually 3D Systems, and they're based in Littleton, and they're interesting because they manufacture their own printers, and then they also they work as a print for service. And another benefit to them is they're located in Littleton, Colorado, so they're right down the street from us, and so we have a really good relationship with them. We're down there. They're either at our site or we're at their site constantly, and we have a very good relationship.
Yeah, I think that proximity is a really good point to make, because a lot of people would just be like, yeah, I'll find some guy in China and ta-da,
Yeah.
And notwithstanding, like China can make really high quality things. I mean, I think it's a lot of people kind of like always like kind of talking down the workshop of the world, but they make really high precision, really innovative stuff. So we shouldn't discount them because of that. But I think, especially with a high quality thing, something that the people depend on, something that you can have a lot of liability, a lot of problems going wrong if it's designed incorrectly. I would really want to have someone who's literally proximate to me, at least in terms of like the time zone and the language, right?
Yeah.
And definitely also visiting and being able to visit these guys is a real advantage.
Yeah, that's a really good point. And to kind of boil it down, I would say, yeah, for advice for anybody else, it would be, I think proximity is actually one of the most important things, and doing a site visit. So this isn't my story, but this is a story of a friend of mine who has a different company in a medical device company still, but totally different space. During COVID, they were trying to ramp up and find good manufacturing partners, and COVID was really challenging because you couldn't do site visits. A lot of these manufacturers weren't allowing site visits, and that turned out to be a major pitfall for my friend. I mean, they ended up going through 2 or 3 manufacturing partners before they were able to finally settle on one, and ultimately it boiled down to, if they had been able to do a site visit, they would have never gone with that partner in the first place. And so site visits and proximity, I think, are really huge.
Yeah, that's a really good point. I mean, people that are really into manufacturing, people like that are manufacturing their blood, they're very different than people that maybe make machines or that do other things. And they will not. First off, they will not shut up about all the standards they have, right? They will not, like ITAR, ISO 9, whatever, right? That's one way to tell the good ones from the bad ones. And then the other thing is they will love for you to visit their site. They will absolutely keep. And usually the ones, especially in the medical field, also in like space and stuff like this, these guys, their sites are impeccable. You should be able to eat off of like every single surface in this whole place. And there should be that kind of guy that there are women, but a lot of them are guys, but you should be that kind of person that really is meticulous day in, day out. And really very, very much kind of somebody who ticks all the boxes every single time and does everything, they're a very process driven individual. And you will know, the moment you walk into the site, you will either feel at home or you'll be like, have this dingy, creepy feeling. You're like, no, this is not, no, we're not going to put this into somebody's body. This is not going to work. You always feel this immediately.
Yeah, absolutely.
So, hey, thanks so much for being on this the show today. This is absolutely wonderful. Thank you so much for your insight, especially like on the hand, but also on like metal printing. We don't talk about that a lot, and I think it's good to get your like very transparent, very honest opinion about that.
Yeah, you're welcome. Thanks so much for having me. It's been a lot of fun.
And Brent, thanks a lot for being here as well today.
Oh, this has been good, and Levin, thanks for sharing your story. I mean, it's pretty wild, and I bet you wouldn't have believed that 10, 11 years ago, you would have been where you're at now with where you're at with the technology and all the stuff. So I think that's so great to see that you're in it for the long game.
Yeah, you couldn't be more right on that. It's been a journey, and very fun, very challenging, but very rewarding as well.
All right. And thank you for being here today, and thank you for listening. This is another episode of the Prosthetics and Orthotics podcast with Brent White and Russ Hughes. Have a great day.